Hey everyone, and welcome back to Three Inquisitive Kids. In this video, we will be looking at the beginning of Chapter 3 in our 8th grade Chinese middle school math translated curriculum that we have made for you guys. So here in Chapter 3 is our unit on the basics of the coordinate plane. Alright, and our first lesson here is identifying points. How and what do we use to identify one point on a 2D plane? Okay, so there's going to be 3 sections to this unit. We're going to have our first lesson here, and we have 2 parts to the second lesson, Introduction to the Cartesian Coordinate System, and our final one, which is Axisymmetric Coordinate Transformations. So we have 2 main goals for this lesson. Our first one is to understand the location of an object in a plane that generally requires 2 pieces of data. And we need to be able to flexibly use different methods to determine the position of objects. Okay, so here is our section 1, determining points using ordered pairs. Think. If in a classroom of rows of students, how can the teacher identify one student's desk? Well, you can think of it, so here's a hint. Given only one data, column 2, can you determine who the teacher is looking for? So what this is essentially saying is if you have grids of students, right, in a classroom and they're sitting in this traditional island sort of arrangement, say there's say only 12 students in this class, and you say column 2. This is column 1, 2, 3, 4. Column 2. Well, that would be all of the students in column 2. You don't know which one you're specifically referring to, right? Because there's rows and there are columns. So what you can do is add in another parameter. So here's number 2, hint. Given the 2 data, column 2 and row 3, can you now identify who it is? So say we have that again, this 3 by 4 grid here of 12 students. You do column 2 and row 3. So that would be this one right here. So this student is the one that the teacher is referring to, right? Because this is column 2 and row 3. So think again. How many parameters or pieces of data do you think is required to identify one point on a plane? So a plane is a 2D space, right? And 2D is 2-dimensional. So the answer to this question would be 2 parameters or pieces of data you need to identify a singular point on a plane. But of course, if you think further, if it was 1-dimensional, you would only need 1, and if it was, say, 3-dimensional, you would need 3. So let's do a hands-on activity here. In a movie theater ticket, what is the difference of the 6 in row 6, number 3, and row 3, number 6? How can you find those seats? So what are the difference, can we ask ourselves, between these 2 phrases? Well, here, row 6, number 3, you have the 6 first and the number 3 next. But for the second one, you have 3 first and 6 next. So how can you find those seats? Well, the difference between these 2 phrases is important because each of these numbers represent, their values they're representing are different. You can think of a movie theater as a grid of seats, right? A grid of seats, so there's columns and the rows. And the column is really just a number here. So we can replace as a column. So row 6, number 3 would be so there's 6 rows here. Number 3 would be okay, so this is not perfect, right? But this is a grid. And here, row 6, number 3 would be 1, 2, let's count from the bottom up. 1, 2, 3, 4, 5, 6. Number 3. 1, 2, 3. So that would be this seat right here. This is row 6, number 3. So this is the way that we can find those two seats. All right, just imagining the grid of seats in the movie theater ticket as spaces to place our points. And each seat can be thought of as 1 point. Okay, number 2. If row 6, number 3 is recorded as 6 followed by 3, separated by a comma and 2 parentheses, then how would you record row 3, number 6? What would 5, 6 represent? Well, here, let's analyze this. Row 6, so this means the row. And number 3, so this would be the number or column. I'll write this for number. How would we record row 3, number 6? Well, we know that the row would be 3, so 3 comes first, and then number next, so 6. So 3 followed by a 6. What would 5, 6 represent? Well, we know that this represents row and this represents number. So this would represent row 5, number 6. Okay, so that's how this would work. And our final thing, number 3. In a cinema with only one floor, how much data is generally required to determine a seat? Well, how many pieces of data did we always use? Well, that would be 2, right? 3, 6, there's 6, 3, 5, 6. Row 6, number 3, that's 2. Row 3, number 6, that's 2. But it says here with only one floor. Imagine a cinema with, say, multiple floors. That would be multiple planes. Well, this is not really the way to explain it, but you could think of it as multiple grids on top of one another. And that is where we can think three-dimensionally. But here we're only covering 2D objects. Of course, you can always think further and think about how that would impact this question, the answer to this question. So our answer would be 2 parameters, row number and column number, or number. So PacMan is probably a computer game that you guys have all played before or have at least known about. Basically requires a little the main character PacMan that's controlled by the user, and it moves around trying to eat these sort of energy spots while being chased by 4 other monsters. And I believe they have specific names. Anyway, if the PacMan touches any of the monsters, generally it dies, okay? So the spots in this picture represent the several positions that the PacMan has passed successfully. So these spots, not the triangles, the spots, are the places that the PacMan has been. For example, 1, 2 here represents the second point PacMan has traveled to, because the first point had been 1, 1. In the same way, represent the other positions that the PacMan in the that PacMan. Okay, so this is a typo right here. Represent the other positions that PacMan has passed through. Okay, so this is just sort of pointing to a point and telling us about the parameters. So here we see that it's a grid and each of these lines are labeled. And every single time 2 lines intersect, of course, that is a point that the PacMan could be at. So this is what labeled 1, 2, 3, 4, 5. This is labeled 1, 2, 3, 4, 5, 6, 7, 8. So a 5 by 8. So a 4 by 1, 2, 3, 4, 5, 6, 7 grid, 4 by 7 grid. But instead of thinking of it as grids now, we want to start thinking of it as intersections. Okay, so it's not the place where we put, so it's not where we don't put the points in these grids, we put them on the intersections of these grids. Okay, so let's do this activity. For example, here, if I pointed to this point right here, you would give 1, 1. Let's just go ahead and fill all of these out. So this would be 1, 1. Why? Because as you can see from the example given, that the horizontal value goes first and the vertical value goes next. So here it's just both 1 and 1 since the horizontal and vertical value are the same. And here you see y and x, those represent something that we will get to later on. But for now, you can think of the x as, just think of them as horizontal and vertical. Now let's do this next point. The horizontal value is 3, and it's followed by the vertical value, which is 2. So 3, 2. So you can also fill this in by yourself as well. Here we have still the horizontal value of x of 3, but now the vertical value is 3. Okay, now this point right here, it has a horizontal value of 4 and a vertical of 3. This one has a horizontal value of 4 and a vertical value of 5. This one has a horizontal value of 5 and a vertical value of 5 as well. This one has a horizontal value of 5, a vertical of 4. This one has a horizontal value of 7, vertical value of 4. This still has a horizontal value of 7, but it is followed by 3, which represents its vertical value. And this final one here is a 8 and a 3. So that hopefully sort of went over what we just discovered in the previous slide, that there are 2 parameters required to identify a point in a 2D surface, okay? And only if it is a 2D surface, a plane. So these are the answers, yep. So can you think of any other ways to identify a point on a plane? So you can ponder on that question by yourself, and then we will get to that at the later in the video. So let's practice. Write the coordinates shown on the plane. So what we have here, so I highly suggest you pause the video and work this out on your own. Here we have another intersection of lines, and this is 15 by 14. So not all of these are placed correctly, but just, fun about. So A here would be 0, 0. So A would be 0, 0 because it has a horizontal of 0 and a vertical of 0. It's right at this point here. B is 2, 1. C is 7, 10. So here's just the answer key. So A is this, B. C is 7, 10. D is 3, 7. E is 4, 2. F is 10, 2. G is 11, 7. So those are the points, the answers that you should have. If not, maybe you miscounted something, so just go back and review what you have. So what objects are on 6, 1 and 10, 8? So first, we can do this together. Let's go to 6. Let's trace our fingers to 6 and then move up 1. So we have a soccer ball there. And 10, 8. So we trace our finger first to 10, move up to 8, and we have a strawberry. So we have a soccer ball and a strawberry. Now there's another way, okay? And this is called the orientation method. And basically, here we see a map of the United States, and we're going to answer questions. Which states are 25 degrees southwest of Virginia? What data is needed to determine the location of Little Rock, Arkansas? And number 2 is, this is Little Rock, Arkansas. What data are needed to determine the position of these points relative to Washington, D.C.? So Virginia is here, 25 degrees southwest of Virginia. We could just measure southwest. So we could first measure south, right? And then 25 degrees west of that. And we follow that line down. I'm going to draw a line that's about what it is supposed to be. This is not perfect, but it will do. So all of these states could count. What is needed to determine the location of Little Rock, Arkansas? Well, here what we have is array, right? We have array from Virginia all the way to, forever because it never stops. It's just 25 degrees southwest of Virginia. But the location of Little Rock, Arkansas, that is a city, and on the map it can be seen as a point. So how can we stop that ray? How can we tell it to stop? This is where you need to be. Well, here we can first get the angle. Let's say 25 degrees as well. This is not exact, but we could say that. So we could do 25 degrees southwest, so southwest of Virginia. You always have to have that Virginia in there because you don't know southwest of what. What are you comparing to? So southwest of Virginia. And when do we stop? Well, you could find the distance between Little Rock and Virginia. This point right here, that's Washington D.C. And you can say stop at whatever, say kilometers or miles. So this is another way to identify a point on a map. So what data are needed to determine the position of these points relative to Washington, D.C.? So we could say there's another city, right? Another city. This is Boston, Massachusetts. I will write, this is Boston, Massachusetts. How can we determine the location of these points relative to Washington, D.C.? So basically it's the same method. We have to tell them the angle, the direction, and where to stop. So that's the pattern we're going to see for identifying points with the orientation method way. And the important part here to notice is that you always need to have that origin as well. The origin. Here it says relative. So that means you got to know what you're comparing to. Are you comparing to Little Rock, or are you comparing Boston, Massachusetts to Washington, D.C.? So you always have to have that relative, that relativity, that comparison. Okay, now here is another hands-on activity. As shown in the figure, the distance between the cargo ship and the lighthouse is 40 nanomiles. How do you use the orientation method to describe the position of the lighthouse relative to the ship? How, in turn, can you describe the position of the ship relative to the lighthouse in terms of direction and distance? So it's the same solution as what we did in the previous problems. We first have the direction and the angle, and then we talk about the total distance here. So this is north. So here's the solution. The lighthouse is 50 degrees south of east from the ship. So, and the distance is 40 nanomiles. The ship is 50 degrees west to the north of the lighthouse, and the distance is 40 nanomiles. So it's this this relativity. You can do it with lighthouse as the origin point. You can also do it with the ship as the origin point. You gotta have the relativity. You have to have the origin, what you're comparing to. So longitude and latitude is another positioning method, especially if you're using a map or something, because those are the lines that you have on Earth to help you pinpoint, say, a city. So how can you do that? There are longitude and latitude lines on the Earth. The vertical lines connecting the two poles is called the latitudes, and the horizontal lines perpendicular to the latitudes is the longitude. According to the latitudes and the longitudes, the correct position of any point on the Earth can be determined. So you can think of this as generally creating a grid, an intersection of lines on the Earth to help us identify which longitude and which latitude to point to. That's simple, right? You could say the number of longitude and latitude and where they intersect. That could be where, say, your point is. So this is just another way you could think of it as an example of using grids, but in real life. Class summary. So here we learn how to identify points, and we learn how to do it with ordered pairs, the orientation method, and longitude and latitude. We also learned about the area positioning method. Here are the 2 skills we learned today as a review to what we covered at the very beginning. Our first skill that we learned is to understand the location of an object in a plane that generally requires 2 pieces of data. So 2 parameters are used and needed to determine the position of one point in a 2D plane. So we did that with multiple different examples. We have the grid using method, and that will develop into something more official as we move on in these lessons. And for the orientation method, right, we need the degree and we need the distance. Our second skill is to use flexibility, different methods to determine the position of objects. So different examples you might given on the different information that you might have, you need to be able to know which method would be the most appropriate for that situation. Thank you for watching through Inquisitive Kids, and see you in the next lesson.